In this session, the content covered would be Introduction to R, Methods of Data Input, Data Accessing, Built-in Functions in R, Descriptive Statistics, Graphs and Diagrams, Measures of Central Tendency, Skewness and Kurtosis. Introduction. Use of the statistical softwares is must for handling large datasets and complex procedures of analysis. Several statistical packages are available such as SPSS, SAS, S+, R, Minitab, etc. Why should we go with R? R is a open source and runs on Unix, Windows and Macintosh. It is a programming language. It has very good computing performance. It has excellent built-in help system, excellent graphing capabilities, easy to extend with user-written functions, can be modified by users, and its development is open to contributors. Scripting and interfacing facilities are available in R. So, how do we install R? The latest version of R for Windows is R 3.1.3. To install R on your PC, first go to the site called CRAN, that is Comprehensive R Archive Network, or you can type its full address http://cran.r-project.org/. Once there, you need to download and install R by running the appropriate pre-compiled binary distributions. Click to choose between Linux, Mac OS and Windows and then follow the instructions. You want the base package and you want to run the setup program which will have a name like r*.exe. When asked, say you want to run. How to work with R? When R is installed properly, we see R icon on our desktop. Click on the R icon to start R. The data analysis in R proceeds as an interactive dialog with interpreter. As soon as we type command at the prompt, that is greater than, and press the enter key, the interpreter responds by executing the command. To end the session, we have to type Q and the parenthesis. How to save, store and retrieve the work in R? So, we can save in two ways. One is directly in R and other is using the Word file. How can we save it directly in R? When you quit the session, just say yes to save workspace image. When you restart R, all the data and variables from the previous session will be available. To retrieve the R command you have used previously, just use up arrow key. We will see how we can save in the Word file now. First, create a file in Word to save commands, say com.word, and create a separate file for output in Word, say result.out. Then copy R commands from R console and paste these in com.word. Once you paste, delete the prompt, that is the less than symbol, from all the commands. Make sure that each command ends with semicolon. The commands saved in R this way can be easily reused to continue the incomplete session or to carry out similar analysis with appropriate changes by using copy and paste facility. Then to save the outputs, copy the outputs generated and paste it in result.out. To copy the graph generated in graphical window, right click on the graph, select the option Save as bitmap and then paste it in result.out. The tables generated in R usually need formatting, hence it is better to paste the table in Excel first and then paste the formatted tables in Word. We will see some R preliminaries now. The data types available in R. The usual data types available in R are known as modes. The modes are logical, numeric and complex. So, what are the arithmetic operators used in R? R includes the usual arithmetic operations with usual hierarchy. So, plus symbol is used for addition, minus for subtraction, asterisk for multiplication, slash division and cap for exponentiation. The hierarchy of the operators is maintained as usual. Spaces are not required to separate elements of arithmetic operators. Assignment operators. R uses the assignment operator less than and hyphen to assign from right to left for the data object, or greater than hyphen greater than symbol to assign from left to right. Example, x less than hyphen 2. This command assigns the value 2 to the object x, and x cap 2 hyphen greater than y. This command assigns the value x square to the object y. If the command is not complete, we see plus at the end of line. Commands are separated by semicolon or a new line. Comments will be line starting with hash mark, that is, text to the right of the hash mark will be ignored by the interpreter. Next, we will see some of the comparison operators. Following are the common comparison operators. Operator greater than indicates is greater than, less than is less than, greater equal is greater than or equal, less than equal is less than or equal, equal is equal to, exclamatory equal is not equal to, exclamatory logical not, and logical and. A pipeline symbol indicates logical OR. Some standard functions used in R. Following are the standard functions that are found on most calculators that are available in R. SQRT indicates square root. ABS indicates absolute value. Sin, cos, tan indicates trigonometric functions. Pi indicates the number pi whose value is 3.1415. EXP and LOG indicates exponential and logarithmic function. Gamma indicates Euler's gamma function. Factorial indicates factorial function, and choose indicates combination. Next, we will see functions in R. Many mathematical and statistical functions are available in R. A function has a name typed and then followed by a pair of parentheses. Arguments are added inside this pair of parentheses as needed. Some function can be used as a method of data input in R. First function is assign function. Example, assign, open the bracket, within quotes type x, then comma 3, close the bracket. Here, assign is the name of the function. The first argument x is the name of the variable to which the assignment is to be made. The second argument is the value to be assigned. Then combine function or C function. The most useful R command for quickly entering small data sets is the C function. This function combines terms together. Example, y, use the assignment operator, C, open the bracket 1, 2, 3, 9, 15, 17, close the bracket and put a semicolon. C function constructs a vector. Even though we have to use the C function to construct a vector, once we have assigned the vector, we may reassign its value to other data objects. The C function can also be used to construct a vector of character strings. Example, names, use the assignment operator C, open the bracket and within double quotes Rama, comma, again within double quotes Lakshmi, comma, again within double quotes Gauri, close the bracket and put a semicolon. The characters are assigned. Next we see sequence operator and sequence function. The sequence operator, it is indicated with colon, generates consecutive numbers while sequence function does the same thing more flexibly. Example, 1:4 command gives the output as 1, 2, 3, 4. 4:1 command gives the output as 4, 3, 2, 1. -1:2 command gives the output as -1, 0, 1, 2. The sequence operator has high priority within an expression. We see an example. 2 star 1:4 is a vector where the output is 2, 4, 6, 8. Sequence 2, 8, by is equal to 2 specifies an interval and increment where the output would be 2, 4, 6, 8. Sequence 0, 1, length is equal to 3 specifies interval and the number of elements where the output would be 0.0, 0.5 and 1.0. Parameters to sequence and many other R function can also be given in named form, in which case the order on which they appear is irrelevant. The first two parameters of sequence function are named as from and to. We see an example. Sequence from equal to 1, to equal to 30 or sequence 2 equal to 30 from equal to 1 or 1:30 will give the same output. Sequence length is equal to 15, 2 is equal to 30, from is equal to 0 or sequence 2 is equal to 30, length is equal to 15, from is equal to 0 are equivalent. Next we see the scan function. We explain this function with an example. Suppose the body weight in grams of 12 rats used in study of vitamin deficiency are given. Readings are 103, 125, 112, etc. Create a data object WT using scan function. We type the commands WT is equal to scan and the parenthesis. Following is the response to the command. So, this we can see it in the console screen. 1:2. Now, type the data separated by spaces. When all the 12 values are input, press the enter key twice. The output will look like 1:103, 125, 112, 153, so on. Then 13 colon. It will display red 12 items. Next we see RIP function. In order to enter the data containing repeated values, RIP function is useful. Example, enter the data set in R 1, 1, 1, 2, 2, 3, 3, 3, 7, 9, 9. The R command is X, use the assignment operator, C, open the bracket, REP, then again within the brackets 1, 3, put a comma, REP, open the bracket, 2 comma 2, close the bracket, a comma, REP, open the bracket, 3 comma 3, close the bracket, put a comma, 7 comma REP, open the bracket, 9 comma 2, close the bracket, again close the bracket and put a semicolon. The first argument to rep function is the number to be repeated, and the second argument is the number of times it is to be repeated. Suppose we have a vector x and we want to repeat each of its element equal number of times, say 4. Then the R command is rep x, comma, each is equal to 4, close the bracket and a semicolon. The next function we see is data.frame function. A data frame corresponds to what other statistical packages call a data matrix or a data set. It is a list of vectors or factors of the same length which are related across, such that data in the same position comes from the same experimental unit. It is possible to create a data frame with the data.frame function. The vectors so included in the data frame must be of same length, or if one of them is shorter, it is recycled an appropriate number of times. Example, suppose we have 4 vectors, x is equal to 1, 2, 3, 4, y is equal to 2, 3, 4, z is equal to 10, 15 and w is equal to 10. We create the following data frames, xz, xw and xy. So, R command, first we will read the values, x, use the assignment operator 1:4, y, assignment operator 2:4, z, assignment operator c of 10, 15 and w, assignment operator 10. First we will create a data frame of x and z, that is D, assignment operator data.frame x, z. The output would be, in the column it would display the serial number 1, 2, 3, 4 and the next column would represent the x entries, again 1, 2, 3, 4 and the next column would output the z entries 10, 15, 10, 15. The first column of the output represents row number. X and z are labeled columns corresponding to vectors x and z. Length of vector z is equal to 2. Length of vector x is equal to 4, which is equal to 2 into 2. Hence, z is repeated 2 times to create the data.frame x, z. Next, D1, assignment operator data.frame x, w. The output is 1, 2, 3, 4, x 1, 2, 3, 4, w 10, 10, 10, 10. The first column of the output represents row or number x and w. Length of the vector w is equal to 1. Length of vector x is equal to 4, which is equal to 4 into 1. Hence, w is repeated 4 times to create the data.frame x, w. D2, assignment operator data.frame x, y. Output is error in data.frame x, y. Arguments imply differing number of rows, that is 4, 3. Observe that longer vector is not a multiple of the shorter. Hence, we get the error message. Example, following table shows the age distribution of cases of certain disease reported during a year in a community. We enter the data using the data.frame function. First column we see the serial number 1, 2, 3, 4, 5, 6. Second column gives the mid age 10, 20, 30, 40, 50, 60, and third column gives the number of cases 5, 10, 120, 22, 13 and 5. R command using data.frame function. We take the variable mid-x, assignment operator, then use the sequence operator 10, 60 and give the increment by 10. Then we take fr variable, we use the combine operator C 5, 10, 120, 22, 13 and 5. Frequency distribution data.frame mid-x, fr. Then if we type fr.dist, we get the output. We see in the output the first column 1, 2, 3, 4, 5, 6, second column mid-x and third column fr. So the data is entered to the R program. Suppose we want to change the names of the columns or rows. This can be done by using call names function and row names function. Call names fr.dist, assignment operator C, open the bracket and within the double quotes if you give mid-age, again within double quotes number of cases, close the bracket, and if we type fr.dist in the output we see that the column names are changed. Next function is matrix function. This is another function used to create a data frame. Consider the example that was used in data.frame function. The data can be input either by row wise or column wise using a matrix function. fr.dist, assignment operator matrix, open a bracket C, again open the bracket seq 10, 60, by is equal to 10, close the bracket, 5, 10, 120, 22, 13, 5, close the bracket, n row is equal to 6, by row is equal to false, close the bracket, semicolon, fr.dist, or fr.dist, assignment operator matrix, open the bracket C, open the bracket 10, 5, 20, 10, 30, 120, 40, 22, 50, 13, 60, 5, close the bracket, n row is equal to 6, by row is equal to t, close the bracket, semicolon, fr.dist. The columns of data set are combined by C function. This is first argument to matrix function. The second argument gives the number of rows. Either we have to give the number of rows or number of columns. N call is equal to 2. The third argument is by row is equal to f. Output, first column 1, 2, 3, 4, 5, 6. Second column 1, 10, 20, 30, 40, 50, 60. Third column 2, 5, 10, 120, 22, 13, 5. To change the row and column names, row names, open the bracket, fr.dist, assignment operator C, open the bracket, within double quotes 1, within double quotes 2, within double quotes 3, etc. up to 6. Then column names, open the bracket, fr.dist, close the bracket, use the assignment operator C, open the bracket, within double quotes mid-age, again within double quotes number of cases, close the bracket, fr.dist. Then in the output we observe that the row names and column names have been changed. Matrix operations can easily be performed in R using a few simple functions like dimension, dim, that is dimension of the matrix, as matrix, that is used to co-erase an argument into a matrix, percentage asterisk percentage, matrix multiplication, T function, matrix transpose, DET, determinant of a square matrix, solve, matrix inverse. It also solves a system of linear equations, eigen, computes eigenvalues and eigenvectors. Next function is class function. This function is useful in deciding the class of the data object. Example, A, assignment operator C 1968 close the bracket colon class A. The output of this command is numeric. A, assignment operator 1:4 colon class A. The output of this command is integer. A, assignment operator C within double quotes x comma y class A. Output of this command is character. Class C semicolon. Output of this command is function. D, assignment operator data dot frame open the bracket x is equal to 1:4 comma y is equal to 5:8 close the bracket semicolon class D. The output of this command is data dot frame. D, assignment operator matrix open the bracket C open the bracket 1:4 comma 5:8 close the bracket comma n call is equal to 2 semicolon class D. Output of this command is matrix. Next we see how we can import data from Excel. Enter the data in Excel with headers, then save the file as tab D limited text file with name say raw data on local disk C and close the file. To import the file in R console, we use read.table function. The R command is data assignment operator read.table open the bracket open the double quotes C colon backslash raw data dot txt close the double quotes comma header is equal to true semicolon. Resident data sets. The data sets that come with R or one of the distributed R packages are known as resident data sets or built-in data sets. We can use data function to access resident data sets in the base package of R. Example, data open the bracket reverse close the bracket semicolon. This will read the data with data function. Reverse, this will print the values of the data set. Help reverse, brief description of the data set, data reverse will be given. Length reverse, it will see how many observations are there. Data, open the bracket, close the bracket and just put a semicolon, it will give the list of all data sets in the base packages. There are resident data sets in other packages, libraries too. We can see the list of all data sets in all packages by issuing the command data open the bracket package is equal to dot package open the bracket all dot available is equal to true close the bracket again close the bracket and put a semicolon. Next we will see some useful built-in functions. Consider x assignment operator C open the bracket 4, 5, 2, 13 close the bracket and put a semicolon. The first function is length function. This gives the number of elements in the vector length of x and the output is 4. Next function is max function, gives the maximum element of the data. Max of x, the output is 13. Next is minimum function, min function, gives the minimum element of the data. Min of x, the output is 2. Range function gives the range of the data. Range x, output is 2, 13. Sum function gives the sum of the values. Sum x, the output is 24. Sum function gives the cumulative sum of the values. Sum of x, output is 4, 9, 11 and 24. Mean function gives the mean of the data. Mean of x, the output is 6. Median function gives the median of data. Median x, output is 4.5. VAR function gives the variance of data. VAR of x, the output is 23.33. Sort function. This function sorts a vector in increasing order of magnitude. Sort x, output is 2, 4, 5, 13. To sort the variable values in decreasing order of magnitude, our command is sort, open the bracket x, decreasing is equal to true, close the bracket and put a semicolon. The output would be 13, 5, 4 and 2. Diff function. This function creates a vector of differences by subtracting previous element from next element. Diff x, the output is 1, minus 3 and 11. To get the list of functions and variables in R, you can use help as follows. Click help on menu bar of R console, select manuals and in that introduction to R function and then variable index. We will see how graphics is used in R. R has a remarkable variety of graphics. There are two kinds of graphical function. The high level function which creates a new graph and low level function which adds element to an already existing graph. The graphs are produced with respect to graphical parameters which are defined by default and can be modified with the par function. List of the function used for standard plots are as below. Plot function is used for scatter plot and some other graphical representations also. Hist function to construct histogram, box plot, box and whiskers plot, strip chart to construct strip chart, bar plot to construct bar diagram, stem to construct stem and leaf display. Next we will see some arguments that can be added to a plot function. The plot function, hist function and box plot function take extra arguments that control the graphic. So some arguments are main that will give the title, x lap that will give the label for x axis, y lap that will give the label for y axis, x lim specifies x limits, y lim specifies y limits, type. It specifies the type of plot. So if we give P, it specifies the points, L it is used for lines and O for lines through the points. PCH, it gives the style of the points. So PCH can take a number between 0 and 20. LTY, the style of the line plotted. CEX, it gives the magnification factor. Next we will see some low level plotting functions. Lines, it gives the line type. AB line, line given by intercept and slope. Points, it will give the type of points. Text, it will specify the text in plot. Legend, it will give the list of symbols. Next we will see some measure of central tendency. Mean in R is computed using the function mean. For example, for the following data 70, 78, 66, 65, 50, 53, 48, 88, 95, 80, 85, 84, 81, 63, 68, 73, 75, 84, 49 and 77 compute the mean and median. The R code is as follows. First, we will enter the data to the variable scores. So, scores, use the assignment operator C, open the bracket and enter all the above values with the help of a comma. Then mean scores will give the output as 71.6 and median scores will give the output as 74. Next, measures of skewness and kurtosis. Skewness and kurtosis in R are available in the moments package. So, to install the moments package, use install.packages, open the bracket, within double quotes give moments, close the bracket. To load these packages, use library, open the bracket, moments, close the bracket. Consider the example. Obtain skewness and kurtosis for the following data 19.09, 19.55 and etc. The R code is as follows. Library, open the bracket, moments, close the bracket. Take a variable x, use the assignment operator, use the combine function and then enter the values with the help of comma and then give the command skewness of x. The output would be minus 0.01565162 and kurtosis of x, the output would be 2.301051. So, we observe that the skewness is negatively skewed and it is plighty-kurtic. To conclude, in this session we have seen how we can enter the data to R software, access the data files in R and compute the simple statistics.